Hello and good day, Algebra. We have our first power objective of the year. It's on the order of operations. Definitely a review, but we're going to be diving into it a little bit deeper, and definitely worth reviewing because it does obviously come up pretty heftily. Heftily? In algebra. And the reason why we have the order of operations is so that if we've got a similar expression, 3 plus 4 times 7, it's a problem if it equals two different things. Think of the chaos that would ensue on a daily basis if an expression was allowed to equal two different things. It's a world I do not want to picture. So, which is correct? Is 3 plus 4 times 7 49? Or is 3 plus 4 times 7 31? Poltinsky.
It's 31 because the 3 and 4 don't have the parentheses.
So what would you do first?
What
would you do first? In your operation choices, you've got addition and multiplication. How would you know to multiply first? Why? You started to say that 3 plus 4 don't have parentheses, which tells me that you're saying we would multiply 4 and 7 first?
Oh, wait. Oh, no. Sorry. My bad.
You are correct, yes. How do you know to multiply first here, Caitlin? Because of the order of operations. And what is the order of operations? PERMDAS. We're all PERMDAS people. That makes me smile. Okay? PERMDAS. PERMDAS, the order of operations. This tells you what order you are to solve an equation in. And what does the P stand for? Parentheses. Is parentheses actually an operation, though? No. You can't parenthesize something, like you can multiply something or divide something. So what's the role of parentheses? If it's the order of operations, but parentheses isn't an operation, what are they for? Eli? It allows you to change the order of operations, right, into something that you want. If we wanted 3 plus 4 times 7 to equal 49, we can make it equal 49 by doing what? Maddie? Where? The 3 and 4, right? We can say, no. I want to add 3 and 4 first, okay? And parentheses are what allow you to do that. So parentheses aren't an operation, but they basically beat everything else. They're like the Joker of math or something. I don't know. But all the other ones are actual operations, and they're kind of separated into different levels, okay? We have a separation marker around the E and the R. What does E stand for? Exponents. What does R stand for? And what's the relationship between exponents and radicals? I'm going to put roots. It means the same thing. But what's the relationship between exponents and radicals? Tristan? They're opposites. Okay? They undo each other. If you start with a number like 6 and you square it, you get 36. What would you do to 36 to get back to 6? You take the root of it, right? Those operations undo each other because if you square something and then take the root, you're right back where you were to start with. Okay, Maddie. Yeah.
And I will get into no, it's PERMDAS. So why do they just not have the root?
So there is a logical explanation for why folks leave out the R, leave out the root, and the reason why is because you can write. Let's see, I'm going to go over here. You can write something like the root of 9. You can write that using a power. Did you know powers can be fractional? So these two things, the root of 9 and 9 to the 1/2 power, stay the same thing. Both of those are a value of 3. Okay? And so what people argue is that because you can write a root as an exponent, it's really kind of the same thing, okay? And I can't argue with that. I mean, they are correct. My rationale for putting r in there is because when we solve equations, think back to the method that you were taught last year to solve for a variable. What was it called? I remember what, yeah?
But it's like you do subtraction, addition.
Right, opposite operations. You know, if there's addition in an equation, to undo it, you would subtract. So often, and I kind of learned this through my teaching career, when people got to something like, x squared equals 100, and they were asked to solve for x, those that couldn't do it mentally didn't know what to do. But PERMDAS people, we see the exponents, and what do we know is the opposite operation of an exponent? A radical. And that's exactly what you would do because the root of something squared cancels out, right? And then you would get x to equal 10 here. So I throw the r in there because it's very helpful when we get to solving equations with roots. My expectation is that you all, having been taught the way of the PERMDAS, when you get to high school and you face a PEMDAS population, you will be my army. Truthfully, I put the R in there just so I can make that joke. That's the only reason why. Yeah. Paul, do you have a question? Army? Never mind.
To the power of 15 16. What would you do?
15 16ths. That one would require a calculator, right? The 15 16ths power. But so you won't see that on a test. Not till Algebra 2, and maybe not even then. Okay. Well, no. It means a little bit different. Let's not go too far down the rabbit hole. But there we go. Yeah. Go ahead, Maddie. Correct. Algebra 2. Geometry is a different branch of math. It uses a different part of the brain. Algebra is a very left side brain. Geometry is a very right side brain. It's a lot more creativity to it. And so you have to stick geometry somewhere because you need geometry for like trig and everything beyond that. Algebra 2, some stuff too. So it's kind of like, where do you put it? Some schools go Algebra 1, Algebra 2, Geometry. Some schools go Algebra 1, Geometry, Algebra 2. It doesn't really matter where it falls. But typically, Algebra 2 is too complex of ideas for 13, 14-year-old brains to handle. It's just the way your brain isn't quite fully developed to understand that yet, most of you. So geometry is a more middle school friendly subject. Most schools use the algebra, geometry, algebra 2 model. So, yeah. Izzy.
If we all pass geometry next year in high school, would we have to take algebra?
You wouldn't have to. You have to take it eventually. It's a state required course. Whether you take it freshman year, sophomore year, junior year, it doesn't really make a difference. But you have to take it eventually, yes. Okay, back to PERMDAS. That was fun. M and D, again, they're kind of their own family. Okay, they're opposite operations. M stands for, D stands for. Okay, and you can probably fill out the rest as well. Multiplication. And this is division. And then addition. And subtraction. Okay, questions on the order of operations so far on PERMDAS? Okay, very well. So basically now you're just going to practice. I did not leave you so much space to write for you to just write your answer really, really big. Just put it in a calculator and, that's not the point there. I want you to show how you work through the equation using the order of operations. So I'm telling you to show your work. You will not be able to use a calculator on this objective on the test, so you can use one to check your answer now if you want to make sure you're doing correctly, since it's practice, but you do need to show your work. And how you show your work is this. What would you do first here? What would your first step be? Yeah. Yes. Parentheses would come first, so you'd underline 7 minus 1, and you'd rewrite the expression with that new value. So because 7 minus 1 is 6, you'd rewrite the expression to be 7 plus 6 divided by 6. Okay. What would you do next? Ryan. Divide 6 by 6, which is 1. So then you'd rewrite 7 plus 1. And now I suppose now you can write it big if you want to. Still enough room there. Okay. But that's how I want the work to be shown. Step by step, tell me what you are doing. Okay. 2 plus 4 squared divided by 8. What am I doing first? Edward. The exponent. And what is 4 squared? 16. So we have 2 plus 16 divided by 8. Next. Nick?
Divide by 8.
Division. 16 divided by 8 is 2. And 2 plus 2 is 4. Okay. Next one, 72 divided by 3 plus 6 minus 2 times 3. Woo! What am I doing first? Katie. I could do the negative 2 times 3 first. What else could I do in the same step? Cole.
72 divided by
Yeah, and why can I do those in the same step? Kaylin. Yeah, they're both in the same family, and one doesn't affect the other. Before we add here, we have to do each of those things first anyway. So because they're not directly connected, we can do them in the same step. Okay? So 72 divided by 3 is 24, plus 6. Negative 2 times 3 is a negative 6. And so we get 24 plus 6 minus 6. I know you can do this mentally, but what can we do now? Maddie. Why subtract first here?
Oh, wait, no, sorry.
Because you're not technically wrong. I'm just asking why you chose to subtract.
Oh, it's 24 because instead of being like, oh, I'm going to add 30 and subtract 6.
Yeah, so most folks would probably say you'd add first, right? For A, because A comes before S in PERMDAS, and B, because you're working from left to right here. But what Maddie said, if you wanted to subtract first, you technically could. Because A and S are in that same family, they are interchangeable. It doesn't really matter which one comes first, as long as you include this sign here, that positive 6. So if you did subtract first, you get 24 plus 0, which is 24. If you add first to get 30 minus 6, notice you get the same answer of 24. So once you get in the same family, it doesn't matter which one is done first. They're interchangeable. Okay? Kind of a fun fact about PERMDAS. The last one here. What would we do first, or what could we do together? This is another one that you kind of have some shortcuts. Nathan.
You could do the parentheses first.
Yeah, parentheses first. Can we do 3 squared in the same step? Why? Why? Why can we do these two operations, even though they're not in the same family? I mean, parentheses isn't an operation anyway, but why can we do them together, Cole? They're not right next to each other. That's kind of what the key is here. What are they separated by? What's in between the 9 plus 1 and the 3 squared? Division. And what do we have to do before we divide anyway? The parentheses and the exponent, right? We have to do each of them before we can divide anyway, so we might as well do them together. And we get 10 divided by 9. Okay? Since we're in algebra now, we'll sometimes get values that aren't very pretty. 10 divided by 9 doesn't work out evenly. I don't want you to be afraid. How could you write that 10 divided by 9? Chase. 10/9. That fraction bar literally means division, and this would be an acceptable answer. Okay? If you had a calculator and you wanted to divide it out and write 1.1 repeating, then you could. Okay? But there's nothing wrong with leaving an answer as an improper fraction or a mixed number if you wanted to. Okay? Everything's fine there. Questions so far? All right. Your homework for Tuesday, because Monday will be mapping. You've got 8 more to practice, more of the same. Show your work, okay? Identify each step as we go down the line. Quiet, folks. Thank you. The next section, it says parentheses can greatly affect the value of an expression. Evaluate each expression when n is 3. So these are all pretty similar. They all contain a 4, an n, and a squared. Some have parentheses, some have negative signs, some have parentheses in different places. Just take a look at how parentheses affect a value, affect an expression. So just doing the first one together here, 4n squared. If we plug in 3 for n, we get 4 times 3 squared. Remember that power of 2 only applies to the 3, not that 4. Okay, the order of operations says we have to square n before we multiply by 4. So what is 4 times 3 squared equal? Don't multiply 4 and 3 first. Order of operations, must square, Nathan? 36. Yep, that's the same thing as 4 times 9, which is 36. But adding parentheses around the 4 and the n changes that, right? Now, this says 4 times 3 in parentheses, and we're squaring that. So in this case, what do we need to do first? Now we multiply. And that gives us 12 squared, and there's our 144. So parentheses can greatly affect a value. They seem such a small, simple thing, but they can greatly affect a value. So pay attention to that as you go along. Yeah, Paul? Yeah, because they're there. You can't just ignore. Think how easy math would be if we just ignore stuff. Yes, it would be awesome, but unfortunately, we can't do that. So yeah, no, you do need to pay attention to parentheses. The next section, as these expressions are written, they do not equal 45. However, I like the number 45, and so I would like you to make them equal to 45. So in this section, you need to add parentheses somewhere in the expression, kind of like we did way back up at the top here, where we added parentheses around the 3 and the 4 to make it 49 there. Where can you put parentheses so that it equals 45? So you're changing the order of operations with parentheses here to make it equal 45. And lastly, the little tick-tock clock, time for review. Reviewing objectives 1 and 2. What is a whole number? What is an integer? What is a rational number? And then 3, simplifying of roots there to practice with as well. All of this is due on Tuesday. Like I said, Monday, please come with your computer charge. We'll be mapping, and we'll finish whatever you don't finish in class or in the morning. We'll do it during math class, so I expect not to have a lesson that day. And this will be due on Tuesday. Woo! Questions, comments, concerns, complaints, comments, congratulations, criticisms.
Congratulations.
For what?
For being a great math teacher.
Ah, shucks. Thanks, Finn. All right, that's how you math.
Don't forget to like and subscribe.
Excellent work.